Hi, everyone, and welcome to the Grid Dialogues, a podcast show where we explore ideas, innovations, and strategies shaping the future of utilities. My name is Sudeep, and I am your host today. In today's episode, we are diving into an important conversation: modern pressures on water utilities and the role of smart metering. Joining me to explore this topic today is Dr. Brad Lusk, a seasoned leader in the water utility space with deep expertise in operations, infrastructure, and innovation. Dr. Lusk is a research scientist turned CEO and policy advisor with 18 years of experience in environmental biotechnology, climate change, electrochemistry, and bioeconomy. He's an accomplished communicator, grant writer, and entrepreneur, having founded five successful companies. Hi, Brad, and welcome to the Grid Dialogues. How are you doing today?
Hey, I'm doing great. How you doing?
Wonderful. I'm doing wonderful, Brad. Thank you so much for joining us. So, Brad, for our listeners who don't know you much, could you tell us a little bit about your background and your work in the water utility space?
Yeah, sure. I have a PhD from Arizona State University in a field called biological design. And when I tell people that, they often ask me what that means. And I tell them that their guess is as good as mine. So we were kind of a new program that started there out of the Biodesign Institute. And we are very interdisciplinary. And my role there, or my research there, was looking at how we use microbes and bacteria to do beneficial services for society. And there is a strong emphasis on water treatment, wastewater treatment, renewable energy generation. And so that kind of led me into the fields of environmental engineering, chemical engineering, and then really thinking about water and wastewater treatment. So was really interested in water quality, water management, and then as well as the things that come after you treat water. So in the case of wastewater treatment, you get sludge management, all those kinds of things. So during that research, I worked very closely with a local wastewater treatment plant that would provide us with sludge, and we would do actual research on the sludge that they were providing and trying to cultivate microbial communities to do these beneficial things. So that kind of led me down this rabbit hole where I got into water and wastewater management and treatment and doing a lot of research there, eventually advising on water and water quality with the United States government in multiple capacities. I was at USAID for a few years. I was at Department of State for a little while. I also did some work on microbes and water at the Naval Research Lab for a while with the US government. I was a professor for a little bit, and then eventually came over into consulting and doing consulting work with water utilities, wastewater utilities, and then a lot of companies that were kind of in the same space I was. So companies that are looking at innovative ways to treat water and to ensure we have sustained access to it.
Wonderful, wonderful. That's great to know, Brad. It's a long time that you have been in this segment, and we are really honored to have you on board today. So, diving into today's topic, from your perspective, what are the most significant operational and financial pressures that water utilities are facing today? What do you think?
Yeah, I think, water utilities, they have a few major issues that are constantly like on the back of their minds. I will say, from my experience working with water utilities, the needs of utilities, whether they're private or public, large or small, right? There's a lot of variance there. And so these issues, while prevalent across many utilities, are going to have differing levels of degrees of severity. And some of the major ones that, I would come across or I come across when I'm talking to utilities or when I'm talking to companies that are trying to serve the needs of utilities, so the people that have gone out and really done the market research. Aging infrastructure is always a big one. Um, just this week, actually, just as an anecdote, in my neighborhood here, there was a pipe burst and the
Mhm.
water was off for 12 hours. And once that pipe was fixed and they buried the hole in, the same pipe broke again. And then once they fixed it again, the pipe at the next house broke,
Oh
right?
my God.
Yeah, it was crazy. So we lost our water for 12 to 13 hours with no notice. And you have to think like, this is old aging infrastructure and things like this are happening, you know, over and over and over again throughout cities every single day, all throughout the world. So aging infrastructure is a huge cost. So you can imagine, I mean, the people that were out there to fix it were out there so long they had to leave and the next shift had to come in, right? So it's
Right.
it's huge costs associated with that. And that's just one pipe. You know, you can think about larger things
Mm.
too, whole wastewater treatment facilities, things like that. Um, Regulatory compliance is another one. So a big one out there is PFAS or these forever chemicals. And regulatory compliance is a huge existential threat to some of these water utilities, especially when you think about wastewater treatment and about people that
Mm.
have PFAS in their sludge, because the wastewater treatment plant didn't create the problem. They're just dealing with it. So the problem's coming in, and now they have this concentrated PFAS in their sludge. And
Mm.
now they have regulations coming in at, parts per trillion, depending on the PFAS you're looking at, could be anywhere from 4 to 10 parts per trillion. And they have to figure out how are we going to actually deal with this problem. Having PFAS in sludge is a very hard problem to manage and to fix. And if you can't now put your sludge anywhere, if you can't bury it somewhere or use it as biosolids for land or cultivating crops, which is another regulation that's coming in where wastewater treatment facilities are able to distribute less and less sludge, in some cases none. Um, how are you going to meet those regulatory requirements when literally the technology is not meeting the regulatory requirements? Even though the technology to treat PFAS and to separate PFAS is rapidly expanding, it's still not quite there. Um,
Mm.
Another big one is aging workforce. So
Yeah.
as people are aging out of the workforce, there aren't as many people to come in and replace them.
Mm.
And as new technologies are coming in too, training people that have been in the workforce for a while or training new people that are coming into the workforce is, not as easy as it would seem. And then as people leave, you're losing that old knowledge too. And so then there's retraining the incoming people that are replacing the old people on how to do the stuff that's been done for a while. Um, Drought and flood, like change in weather patterns, changing climates, right? So infrastructure that was set up, decades ago now is having to be upgraded to deal with the consequences of the water levels being higher, right? You think about where a lot of from a US perspective, where the largest cities are concentrated, the New Yorks, the Bostons, the San Franciscos, the Seattles, right? These are all coastal cities. Most of the population is actually concentrated on the coast. And so you have
Yeah.
wastewater treatment and water treatment facilities that are at these lower elevations. And as the sea level's rising, they're at a really big threat of being inundated with this salty water. And then you have security threats, right? Data security, cyber security. You can think about ransomware attacks that have happened on pipelines already. And so this is something that the water industry is constantly thinking about. And then you also have consequences of like rising costs, right? So there are rising costs associated with your infrastructure and your operational costs and updating, capital costs, all these things. And you have your revenue that's regulated, right? So what you're charging for water, that's generally regulated. So you can't just increase that necessarily overnight to meet your rising costs. So you end up with a deficit of revenue that you
Yeah.
need versus costs. And so you have to think about, or, water suppliers are having to think about ways that they can bring in non-regulated revenue. An example would be like selling you insurance or warranty on your pipes, right? How can they bring in non-regulated revenue? How can they charge to bring in money so that they can manage their day-to-day business other than trying to charge a customer more for their water, because it might
Right.
not necessarily be able to do that. And then the last one I have, yeah, I was just emphasizing that equity and aspect and access aspect, right? So water and water utilities want to make sure that they're able to kind of confront these financial pressures and operational pressures while
Mm.
ensuring that, especially in this case of a public utility, right? Their job is to supply the public and the people that they serve, their communities, with water. So they need to make sure that they're able to sustain that supply and make sure that people have access to it kind of as a, almost as a fundamental human right, you know?
Right, right. And Brad, then what about issues like, leaks or thefts or, network inefficiencies as well? I'm sure they also contribute to these challenges, right?
Yeah, I mean, so non-revenue water or water leakage
Yeah.
is always a major issue, right? And so water utilities are really interested in detecting leaks quickly.
Hmm.
I mean, obviously, if you're just losing a bunch of water in your pipe somewhere, or there's a leaky faucet somewhere or something like that, like that solves, you think about the whole process of the water coming in and the water getting treated and the water being distributed, and you do all of this work just so that the water can end up, being dispersed out somewhere random because it's leaking in a pipe from aging infrastructure, things like that. And so water utilities are trying to figure out ways that they can detect these leaks in real time, which I think gets us into, another part of the discussion, which is around like different ways that water can do metering, right? So you have AMI, which is like advanced metering infrastructure, and
Yeah.
this enables water utilities to kind of basically there's like a multi-directional communication there, and usually the signal is being sent through like cell phone towers or something like that. And you could think of a traditional, like when I was growing up in the 90s, I remember watching the metering person go up to our meter and actually look at the number every time,
Yeah.
which was crazy, you know? And and so like AMI is trying to eliminate that, essentially make it so you don't need a truck to drive by and pick up a radio signal or a person to walk by and have to look at your meter. And it's kind of just a one way where the meter is sending a signal or the person's looking at a number and collecting a number. You want to be able to go both ways. So you want to be able to hear from that meter and then communicate back to it. And really, when you're able to do that, you can get a larger amount of data. And with that larger amount of data, you can look for these discrepancies where it's like, oh, all of a sudden, like there's a ton of water being used at this location consistently over the course of this period of time that we have never seen happen before. That could be a leak. Can we turn this off and go look at it? Or can we make a phone call immediately to the person that, maybe there's someone responsible for paying that meter and they're like not going to be happy when this huge bill shows up. So it
Yeah.
just enables that detection like faster. So there's less of that leakage and non-revenue water.
Lovely. And what do you think? Like, since you already spoke about this entire smart metering or AMI, being set up, what are the factors that you feel are influencing the pace of this implementation? Because the information that we have, or in the word that goes around it, sometimes it becomes really slow. So what do you think are the factors really?
Yeah, I think the factors that kind of impede the adoption of AMI, again, just to emphasize varies depending on who you're talking to.
Hmm.
So, for example, a cost, like that initial cost, that upfront cost is always going to be a factor, right? And you can think about economies of scale.
Hmm.
And so in terms of installing, meters, you're probably going to get a better deal if you're installing, say, 50,000 meters on a larger kind of infrastructure change for a larger city than, say, 500 in a smaller rural area. And what's interesting about smaller rural areas, um, some of them are seasonal, for example. Like I can just think, where I grew up in Arizona, there were a lot of like seasonal cities up north where you do have a population that's there for a good part of the year. But you also
Yeah.
have people, from the hot desert that only go up to, Flagstaff or Prescott or Pine Top or Show Low or places like this during certain parts of the year. And so
Right.
what you end up with are like these really uh like dispersed, meters, and you only have maybe a few hundred of them or a few thousand of them, and you don't have as much money in the coffers of the city to pay for this, and you only have people that are there seasonally, so they're not always necessarily like consistently paying into that system or paying utilities in a way that you would get in a city where there are just people living there all the time.
Hmm.
So compounding that issue is, well, you don't have AMI, but now you have a leak. No one's there. Think about the winter months when the pipes are freezing over, like, and you might get a leak, especially as things
Yeah.
start to flaw. Well, no one's there. No one's
Hmm.
there for like 4 or 5 months, right? And so
Hmm.
this is a huge issue in these rural areas where they want to be able to detect the leaks, but they don't have millions of dollars to invest. Maybe maybe Flagstaff does. Flagstaff's not a small city. Don't get me wrong, but some of these smaller rural cities that I've talked, some of the ones I've talked to in Iowa, for example, where they have 500 meters or 1,000 meters, like it just doesn't seem very realistic to them to get, you know, millions of dollars to be able to spend on them.
So as you mentioned, right, these are all factors affecting, but I'm sure there are there could be organizational factors also, sometimes technical factors also that affect these large scale meter deployments specifically.
Yeah,
Apart from
yeah.
what you mentioned, what do you think? Yeah.
Yeah, yeah. Thanks for bringing. I was like, I think I forgot another half of that. Yeah, so with the larger utilities, some of the pain points that I've heard are it's the integration of the old with the new. And so, for example, I spoke with a city that serves, I can't remember, they had like maybe 30 or 40,000 meters, right? So this is maybe like it's not like huge, it's not Houston, but it's a mid-size operation, I would say, mid to large size operation. Um, and they have smart metering, these AMI systems installed in 90% of their systems. And it's the other 10% that prevent them from doing leak detection because those 10%, the meter readings aren't synced with the software, aren't synced with the system. And so it makes it, you know, if they don't have accurate numbers between the two, it makes it really hard for them to use that across the system. There's also the human aspect of it as well. And so we talked a little bit about it before, like the workforce turning over or the workforce having a difficult time finding people to fill those positions. And so you have training on new technology that comes in, and the training of people that have been doing it a certain way for a long time isn't necessarily the easiest. And then the training of new people that have no experience at all isn't necessarily the easiest. And then the integration of that technology in terms of getting the old data and the new data to like communicate properly and getting some of the old software to communicate with the new software that's being used for the AMI system. And so the integrator needs to come in and do a custom kind of software package and integration, usually on a one by one kind of scenario, because there's not necessarily what's the word I'm looking for? Like consistency across all of the utilities in terms of what they have been using and what they are using and what hardware they're using for AMI and what software they're using for AMI. And so all of these add like, extra levels of complexity, and then you have different needs. The Southwest is going to have fundamentally different needs than the Northeast in the United States, for example. And so they're more interested in certain things than the other ones are. And so it just makes everything, if you can't do, you think about like a pen or something or some basic thing like a razor, you could just print like millions of these and just ship them off. And it's really easy to think about scale. That's a little bit harder to do when you're thinking about all of these levels of complexity and all of these ways that each customer you deal with has unique needs that you have to address and customize for.
Absolutely. Yeah. And Brad, so what do you think? Like, how can modern field operations tools improve the installation, commissioning, and maintenance of this entire metering infrastructure? Because as you said, there are multiple systems that are being used. There is no consistency around it. So, do you think these modern tools could be of real help here?
Yeah, they're cool. So when I was so I used to help a lot of companies that were trying to like sell to um, water treatment, water utilities, wastewater treatment plants, things like that. And so I saw a lot of really interesting kind of tools and tech that people were innovating. Um, and so You can think about so a simple one is like just replacing paper with, you know, electronic files and forms that can easily be shared and corrected and things like that. But you also have like, in terms of thinking about installation of new infrastructure, um, you have now different kinds of technologies that can look underground to do better detection of where, say, a pipe is, right? So if you want to lay a new pipe, or say you want to lay electrical, or you want to replace an old pipe, right? If you want to install new infrastructure without busting an old pipe, you need to know where that pipe is. And a lot of these old maps that were made of where the pipes are off, right? And they're not like it's not egregious. It's not like people were neglectful. But if you make a map and it's off by 2 feet or a meter, and you go to dig a hole a meter and it's off by a meter, you're going to hit that pipe. It just happens, you know? And so now people are building software or they're building hardware where they can literally like detect in the ground up to a certain, a few feet or whatever deep where a pipe is in real time. And it's kind of, I've seen one where it's built right into the scoop that's on the crane and it just hits the ground and it tells you if there's a pipe there. And if there is, then they don't dig there and they have to go back to the drawing board and think about, okay, well, where can we dig to put in this new pipe? Right. Another cool one I saw was like custom tutorials. So in terms of operating software or new equipment, you can actually have people come in and they will make custom tutorials on how to use the equipment at your site. So they will make videos of someone at the company showing other people at the company how to use this software package or how to use this hardware. And that gets uploaded into a system where it's like an internal YouTube system, right? So then people can look up these videos. And another cool thing that I've seen is taking the manuals. So you could take all the manuals of all the things that are used at your facility, and you can upload those, and then you can have people have conversations with AI about those manuals and how to operate things and how to use it. And so you have these videos that are custom made coupled with this AI that's been trained on the manuals for all the equipment that you use as a way to kind of assist with field operations implementation, all the ins and outs of how things work at your particular facility.
Right. And Brad, since you spoke about AI, that's actually my next question. That since it's the current big thing, everywhere and anywhere that you go, how do you see AI really, really helping water utilities to get more long-term value? Uh, from their smart metering data or from any other ways that you feel are right.
I think within water utilities, within a lot of these kind of, I don't want to say older, but these kind of more traditional jobs, they've been around for a while. You can think about water, you can think about electricity, things like that. Um, but these are situations where for years there have been really intelligent individuals looking at, processes, needs, and using their, engineering acumen to make decisions. And the desire to maintain that human element as the decision maker is alive and well within the water utility space. And so when we're talking about AI, we might be, in the context of water utilities, you might be thinking about like narrow AI, right? There are a few different ways to think about AI. You have narrow AI, which is essentially like machine learning. You have general AI, which is as smart as a person, and then you have like super AI, which is, Skynet or whatever. But it's AI that's smarter than a person could be, right? So I think water utilities, uh, I do think there's buy-in amongst a lot of them, but not all of them, amongst some of them, I should say, around general AI and the ways that they can use general AI to increase efficiency. One of the big ones I saw was this desire, how do we increase efficiency around customer service, for example? So if a customer has questions about their billing, can they talk to an AI bot to get their billing information or to pay their bill? Or we're talking about smart metering. Um, if they have specific questions, so with smart metering, they get an app and the app would show them real-time usage. And if they have questions around that real-time usage, they could talk to AI about the real-time usage, right? So just streamlining that customer service process so that they don't need to dedicate as many work hours to creating forms for people. We mentioned it before, leak detection is a big one. Basically, if you can have AI looking at this big data, again, narrow AI looking at this big data and just seeing patterns that it usually doesn't see, saying, hey, maybe that's a leak. I've also seen monitors on pumps. So you have monitors on pumps, and these monitors are monitoring, just the movement of the pump over time. And what these monitors can actually do, because they have such a huge data set and they're looking at the movement of this pump over time, they can detect very minor fluctuations in that pump. And they can say, hey, a bearing's going out on this one. We need to fix it within this amount of time. And if we don't, we're going to have a failure here, right? So again, narrow AI, it's just doing machine learning. It's just looking at big data and looking for patterns. But that could be, I've seen utilities already starting to integrate that as a way to just save on maintenance and do more preventive maintenance and also not have these catastrophic failures where, now they got to turn off someone's water for several hours or something like that.
All right. Wonderful. That's it for now, Brad. That was my final question to you. Uh, and thank you so much for answering in so much of depth. It was great to chat. Is there anything else that you would like to share with our audience today on this podcast?
Just, Sudeep, it's been an absolute pleasure talking with you. And if anyone has any more questions or wants to talk to me or is interested in learning more about this field, yeah, feel free to reach out using the contact information that we'll provide to you.
Definitely. All right, wonderful. It was pleasure to have you today on the Grid Dialogues. Thank you so much for joining us. Uh, and for all our viewers, if you enjoyed today's episode, or if you would like to have a particular topic that you would want us to cover on the Grid Dialogues, please let us know in the comment section. So that's it for this episode today of Grid Dialogues. See you around next time.
Cheers.
This podcast is brought to you by Grid, a platform helping electric, water, and gas utilities maximize their value of smart metering and operational data. Feel free to follow us on our website and LinkedIn. You can find the links below in the description. And if you like this podcast, please do the usual: like, share, and subscribe to our channel.